Hello everyone, let's talk about another medium problem on Leetcode today. Merge nodes in between zeros. Leetcode 2181. In this problem, we are given the head of a linked list which contains a series of integers separated by zeros. The beginning and end of the linked list will always have node value equal to 0. Then for every consecutive zeros, we have to merge all the nodes lying in between them into a single node whose value is equal to sum of all the merged nodes. The modified list should not contain any zeros. We have to return the head of this modified linked list. Then they have given some examples. In example 1, we can see that the linked list is starting with 0 and ending with 0. And then there is also one 0 in the middle. So we merge nodes 3 and 1, which is shown in green color. And the sum is 4. So we will add it to our answer. Then similarly, we add up all of these red nodes as well. So the sum is equal to 11. And we will again add it to our output. Similarly, in example 2, the list starts and ends with 0. So then we see 1 between two zeros. In this case, there is only one node, so we will just add it to the output. Then comes 3 between two zeros, and then we will again add it to the output. And after that, there come two consecutive 2's between two zeros. We will add them up, which will be 4, and again add it to the output. Now let's see how we can actually solve this problem. One of the easiest way to solve this problem can be that we actually create a second list, which will be actually storing these sums. So we will start traversing from the non-zero node in the list and start adding the values to the sum. And as soon as we see a 0, we actually create a new node and set the value equal to sum and add it to our output list and reset the sum equal to 0. And then continue till we actually reach the end of this given list. Even though this solution works and it is simple and efficient when it comes to time complexity, we cannot use this solution. And the reason for this is, in this problem, they have specified that we have to modify the linked list in place instead of creating the new nodes. So we can't use that solution. But if you notice in the previous solution, we are actually using two pointers. One pointer is iterating over the original list where we are actually calculating the sum. And second pointer is in the output list, which is actually creating the new node and then moving to the next pointer in the list. Because we have to modify the list in place, both the pointers should lie in the original list. So what we can do is, let's call the part of the list between the two zeros a segment. We can actually create two pointers, start and end pointers, where start will be actually pointing to the start of the segment and end will be traversing through the list till we actually reach the end of the segment. And now we can actually start summing up the value based on the end pointer and start traversing the list segment by segment. Let's jump into the example to understand it better. And generally in these kind of problems, when we have to modify the linked list, we generally use dummy node, which is nothing but just node pointing to the head. But in this problem, we don't even have to use that because first and last values in the linked list are 0 and they are anyways dummy nodes because they don't have to be part of the output in the final list. So let's take the first example. Now we point our dummy pointer to the start of the head, and in the end, we will just return dummy.next. So we will use two pointers, start and end. Start will be denoting the start of the segment between the two zeros. And we will actually use the end to traverse through the segment, sum up all the values, and find the end of the segment. Let's see how we can actually do that. So initially, both start and end will point to the start of the list, which is 3, and our sum will be equal to 0. Now we will see what is the value of end here. It is 3, so we will add it to our sum and move end. Then n comes at 1, and now again we will check what is the value of the node at end. It is 1, so we will add it to our sum. So sum will become 4, and we will move n to the right. And as soon as now n finds 0, that means we have found one segment in the list. So we will actually set the value of sum at the start because we still have the start pointer pointing to it. And then we break the list and point to the next segment, which is n.next, because we know that after 0, the next segment starts, and move the start pointer to the start of the next segment so that we can start processing that segment. And once we continue, we will actually again set sum equal to 0. Again, end will be equal to start, and then we will again iterating through the loop. So sum will be equal to 4 because that is the value of the node here. Then when we reach 5, sum becomes 9. When end reaches 5, sum becomes 9. Then when end reaches 2, sum becomes 11. And we again reach 0. So that means that's the end of another segment. And now we will actually set the value of start where the start pointer was to sum equal to 11. And now we have to break the list from here because these two nodes are not useful anymore because we already have the sum at 11. And we will just move the next pointer to the end.next, which is null in this case. And then eventually we will return the dummy.next, and that will be our answer. So I hope this was clear to you. Now let's jump into the code part. So first thing we'll do is like define dummy equal to head, and then we will just define the list node start, which will be at the start of the first segment, right? Which is head.next. And then we will now start traversing the list segment by segment using the start pointer. We will define our sum variable, which is initially equal to 0. And now we define the end pointer, which will help us traverse a segment and accumulate the sum. And initially it will be equal to the start. We will just sum up the values here, and we will keep on iterating with the end equal to end.next. Now we are actually out of this loop, so that means one of our segment has ended. So we will just set start.value equal to the sum we have accumulated so far. Start.next is equal to end.next, right? Because we have to now point to the next segment. Note that there is one constraint here, that there are no two consecutive node value equal to 0. So that's why we are able to do this, where we are setting start.next is equal to end.next. If this constraint does not hold true, then we may have to run another while loop to find the end of the consecutive zeros. In this case, it's simpler, so we don't have to use it. And then we will just say start is equal to start.next, because now we will start processing the next segment. And eventually we will just return dummy.next. I hope this was clear to you. Now let's run this code. Awesome. Let's submit this code. Cool. So in terms of time complexity, it is O of n, where n is the length of the linked list. Because we are processing each node only once, right? So even though the loops look nested, the start loop is actually jumping to the next segment instead of going through all the elements and again and again. So that's why it is just O of n. And in terms of space complexity, it is O of 1 because we are just using constant pointers like dummy, start, and end. When it comes to solution, there are other solutions possible as well. Like for example, there is a recursive solution possible. Please check it out on my blog. I prefer iterative solution here because it's simpler to read and it does not use any extra stack space, but it's up to you. I hope this video was useful to you. If it was, please like and subscribe. Have a nice time. Thank you.